Mars exploration from the U of A makes its way to the silver screen.
I just saw the movie last weekend, and I was just thrilled to see that our Pathfinder camera is one of the stars of the show, because this becomes the communication path from Mars to the Earth. Retrieving of the old Pathfinder system, powering it up again after all these years, and then using it to communicate both pictures and data. Really exciting to see our camera used that way.
Sustaining life on the red planet will go inside the Mars greenhouse.
Each unit should be able to produce 50% of the calories needed by an astronaut per day, and at the same time completely recycle oxygen, carbon dioxide, and water.
This is Arizona Week. The Martian, a movie about Mars, out just a few weeks. In the science community, it's considered to be one of the most realistic space movies of all time. At the University of Arizona, scientists have been working on early Mars exploration. Here's the principal investigator of the Phoenix Mars mission. Peter Smith, a professor emeritus here at the University of Arizona. Describe to us where we are sitting currently.
We're sitting in the Mars Garden. This is part of the University of Arizona's facility for testing Mars cameras. We built it here, the Pathfinder camera that is, in 1995 and tested it right in this space. And it's been Mars-like ever since.
Tell me, what is your fascination with Mars? How did this all get started?
It started when I was a child reading science fiction. Like most scientists, I was fascinated with science fiction and explosives. So both of them came together in the idea of exploring Mars, the launch, the long cruise, the landing, and then the extremely beautiful landscapes on Mars that we've been puzzling over for years.
How would you describe Mars to people?
It's a very desolate place. Unlike the Earth, it's covered in craters from impacts from all the asteroids that have hit it over the last few billion years. They're still there because there's very little rain, in fact probably no rain, maybe a little snow, and the erosion rates are extremely slow. So it's a planet that had its glory days several billion years ago and now is kind of a dormant place.
How diverse is the climate on Mars?
Well, Mars has an extremely thin atmosphere. So in the daytime it might get up to 50 degrees. At night it might go down to minus 150. So it's an extreme condition day to night, every day and every night.
The windstorms, can you explain how that happens?
Well, because the atmosphere is so thin, the windstorm in the Martian was a little exaggerated, maybe a lot exaggerated. The amount of air that's actually moving past, even in a strong wind, is not enough to pick up an antenna and go throw it for, into an astronaut. It's just not that strong.
You get the go-ahead to do research on Mars. Tell me about that experience, knowing that we can finally check this place out.
Well, we were thrilled to have a chance to build a camera, and we thought we'd build the best camera we possibly could for the amount of money they were giving us. And so we put in special filters, and the special filters allowed us to do things way beyond a normal camera. And for instance, one of these rocks here on the surface, you see it's kind of greenish. Our camera could have picked this up like a searchlight. This is olivine, which on the Earth we retrieve from rocks that have been pulled up from 10 or 12 miles under the surface. And these are the rocks that make up the mantle of our continent. So we were looking for things like this, clues within the rock structure of the surface that would tell us the history of Mars. July 4th, 1997. And this had been a small mission for NASA and not much publicity. So we happened to land on July 4th, which wasn't exactly an accident. We knew we'd land on July 4th. But nobody was too sure whether we'd see pictures the first day, whether just what would happen. But it turned out to be a slow news day on a Friday before the July 4th weekend, and lots of people were watching television all across the country. So when we came down, bouncing onto the surface, and the pictures started to come back one by one, there was tremendous excitement. It went worldwide.
Part of the reason I invited you on today is this movie, The Martian. This is intriguing to a lot of people. You've kind of known this for a really long time, though, about Mars. Well, what are you most fascinated to find out about Mars?
Well, I just saw the movie last weekend, and I was just thrilled to see that our Pathfinder camera is one of the stars of the show, because this becomes the communication path from Mars to the Earth. The retrieving of the old Pathfinder system, powering it up again after all these years, and then using it to communicate both pictures and data. Really exciting to see our camera used that way.
How big is the camera? I mean, you know, you see it in Hollywood, but I mean...
Well, we used to say it's the size of a Foster beer can. It's about this big, 8 inches across, 4 inches in diameter. And also, it has eyebrows. And so the reason is, when it looks straight down, the eyebrows protect it from all the dust. And so, for the same reason we have eyelashes and eyebrows to protect us when it's dusty, this camera had them also. So it's a really humanoid type of camera.
Tell me what some of these pictures have shown you about Mars.
Mars is known to be a rocky place. So we go there knowing you're going to have dust and rocks. So that's what we know we're going to see. Now we're also looking for traces of water activity. And water being the basis of life on the Earth, anything that tells us about the history of water would be very exciting. And we did see some hints of that, not so much at the Pathfinder site, but on the next mission I was involved with, the Phoenix mission, we are actually able to dig under the surface and find ice, water ice. And this is exciting because it tells us that water is a very common ingredient of the Mars surface. It's just not raining up there, and it's mostly in the forms of ice or very heavily salted water.
Alfred McEwen is a professor of planetary geology at the University of Arizona, also the principal investigator of HiRISE for the Mars Reconnaissance Orbiter. Dr. McEwen, thank you so much for being here.
Hi.
Start off with telling me about what your thoughts were about The Martian.
The Martian was a terrific movie. It portrayed science, the science process, and scientists in a positive and more realistic manner. Scientists actually having a sense of humor. Who knew that was possible from Hollywood, right? And terrific job, great scenery, beautiful story, a feel-good movie. It was definitely recommend going to see it.
Behind you, we have some photos of what the images have been sent back. Tell me a little bit about HiRISE.
So HiRISE is the High Resolution Imaging Science Experiment, and it's a big camera that we send to Mars, and we acquire images of about 30 centimeters, about a foot per pixel on the ground. So this is the highest resolution of any other planet images. We've been there for almost 10 years now, actually. So we acquire these very high resolution images. Some of it's in color, and we pick out targets of interest based on various rationale for various science investigations. For future landing sites is a big purpose of HiRISE as well.
And HiRISE is still transmitting images even today?
Yep, HiRISE is in business today. We'll get new images every day.
What are you most proud of when you see these images? I mean, it's capturing what you wanted it to, it's doing what you wanted it to do.
I love every HiRISE image. It's always just remarkable to look at them and see the sharpness of the features, and the more the better.
How many spots is it actually going to each day, or the orbit? Would you describe that?
So it's a circular orbit. It circles Mars about 12.8 times per day, and we can take 1 or 2 images typically per orbit that we select, and we have access with pointing to within about a 2-week period of anywhere on the Martian surface.
Has HiRISE shown you anything that maybe really just surprised you or caught you off guard?
Certainly a number of things, and one particular topic which had quite a bit of attention a couple of weeks ago are these recurring slope lineae, terrible acronym, but people are starting to get used to it. And these are seasonal features, flows down slopes, and they're associated with water in some way, liquid water today on Mars, so that's surprising.
So when all the excitement about water on Mars came out recently, that was the photos that were spotted here at the U of A.
Right, that was, originally we discovered these features with the HiRISE camera. The most recent result was from the imaging spectrometer, a different instrument that measured the composition.
What is the size of HiRISE? How would you describe that to me?
Well, it's about a 1/2 meter diameter primary mirror. The whole thing is about the size of a person. So that's big for something that we send to another planet. It's not big compared to what they do in the Mirror Lab right across the mall here, which are much bigger telescopes.
You're currently working on other missions. Can you tell me a little bit about those projects?
Sure, I'm working on the camera for the next Mars orbiter that Europe is launching, called the Trace-Gas Orbiter. I'm working on the Lunar Reconnaissance Orbiter and the camera there. The Cassini mission that's been at Saturn for over 10 years now. It's got a few years left. And the new Europa mission. I'm the deputy PI of the Europa imaging system.
What is the hope out of these missions? I mean, to continue doing what for example, what HiRISE is doing?
Yes, some of these are continuing missions for the Mars mission, the Trace-Gas Orbiter. It's more lower resolution, but all color, more color imaging in different times of day, so that'll be unique. For the Europa mission, we get a range of resolutions, but the very highest resolution during the closest pass to Europa will be similar to HiRISE images, but of Europa.
Going back to the film The Martian, some reports have said that it was very well done. It's the most realistic space film that we've seen in a long time, maybe the only one we'll see. Do you suspect that maybe this is good for the industry, so to speak, with what you're doing and what is happening here at the University of Arizona?
It's all good, for sure. This will help promote interest in science and Mars exploration. It may not transform NASA or anything like that, but it's good.
Wonderful. Thank you, Dr. McEwen. NASA hopes to have manned exploration to Mars sometime in the mid-2030s. How an astronaut would sustain life on another planet is being researched here in Tucson. Professor Roberto Forfaro, a space systems engineer, took us inside what's known as the Mars greenhouse. In the film The Martian, we see that the astronaut is able to make water for his greenhouse. How likely is that? Is it totally hollow?
Actually, that's an interesting point, mostly because these systems are called bioregenerative because they are able to recycle, certain components. One of these is water. Indeed, we have one component here, which is currently analyzed and tested as a separate system, so we don't have the system fully closed. It's called weak evaporator composter. Basically what it is a system where you take all the waste, including biomass, right? For example, when you harvest, right, and you take your crops, you have a lot of inedible biomass. In this case, this is considered waste. You can go inside to other waste, for example, human waste in a composter, and the system digests and processes them. Basically transform what is called black water into gray water. Gray water is still not potable. Nevertheless, can be absorbed and used for plants irrigation. Indeed, what we do together with nutrients, we stream it to the plants in our hydroponic system without soil. The plants, what they do, absorb water, absorb the nutrients, and periodically they perform what they call evapotranspiration. Basically, they emit water vapor in the atmosphere. If you have a condenser, then you can condense water, and here you have completely white water, potable, that you can use it. So the revitalization process the plants are capable of play a role because then the water is still in circle. Indeed, one of our byproducts of the experiment is also measuring how much water we're able to collect per day, right? And measure how much we're putting into. So we're trying to kind of establish if we can have what we call a water balance.
Roberto, so we're inside a prototype of one of these greenhouses. If you would start by describing the light system in here.
Right. The light system is an important system because you need the light at a certain level of intensity to grow plants, right, in any condition. So conventionally, for greenhouse, earth, and also space-based application, you use something called high-pressure sodium lamps. They're extremely power-hungry, right? And here now we're experimenting a different type of light system, which is provided by Philips. It's an LED-based, right? They're supposed to be much more efficient, and of course, this will help us because the power that you need to grow this system, which is a bioregenerative life support systems, needs to come from somewhere, and usually mass and power are extremely precious commodity in a space travel. So we're trying to experiment different light levels and different type of hardware so that we find the optimal solution to minimize power.
Now tell me about the crops that are in here.
We're experimenting with what we call a polycultivation system or multi-crop system. This is something NASA hasn't done. Historically, they grew in their closed loop testing for growing for bioregenerative life support and growing just one crop at a time. Here we have a one-to-one facility that we can try to put different type of crops. And our goal, as a matter of fact, for one of these units, and we have 4 of it, is that one unit can support 1 astronaut producing 50% of the calories per day, while at the same time closing the oxygen loop, the water loop, and the carbon dioxide loop. What it means basically be self-sustained with the ability to produce 50% of the calorie per day. That's our target goal, but to do so you have to put different crops together. For example, what we have mostly here, we have sweet potatoes, right? Sweet potatoes are one of our preferred crops because the potatoes are packed in calories, right? So they increase the calorie output, per astronaut. We also have lettuce here. We grow lettuce, and we also have basil, strawberries, these kind of things. Of course, at this point, we're not on the point where we have, we're going through usually a 3-week cycle, so we don't have the ability. I mean, we don't have crops at this point.
No soil in here.
Absolutely no. Those are hydroponic systems, and here, University of Arizona are really world experts in hydroponic systems. What we've been doing, basically, we came up with this cable culture system. What you see here, more specifically, is a set of pockets, right? And inside the pockets, basically what you do, you put seeds, and nutrients are flowing down inside, right, here. And as you see, basically, we don't have any soil, right? Now, this cable culture system, as we call them, also they're strapped, so you can kind of tie together. And what happens is that they're flexible, and indeed this structure, the way we conceive it, is basically can be collapsed and inflated out, right? Now you see, of course, in full deployment, and it's fully expanded. But either on the moon or on Mars, what you would do, you would just compress it, right? And the cable culture, it's flexible enough that it can be pretty much packed in. You can put quite a bit of seeds inside, and then once you arrive there, robotically deploy, have the nutrients, the water and the nutrients flow down, and automatically with a 3-week cycle grow crops. The idea is to deploy this ahead of the arrival of the astronauts, so that once they get there, they have fresh food available.
Describe the size in this. Well, why is it structured like a cylinder?
Well, this is structured as a cylinder because originally it was conceived for moon deployment. Basically, what we have conceived, I think in 2008, a system that an inflatable system that would be deployed on Mars, and the system was conceived on a central hub and different inflatable cylindrical spokes, right? And 4 of those units will be greenhouses. Will be actually a bioregenerative life support system for food production, oxygen, and water revitalization, and so on.
So we send a man to the moon or Mars for an extended period of time. He or she would be able to sustain their life, or food-wise.
Yes, that's the idea. Of course, this is a test bed. There's a lot of challenges, to do it, but we're testing, we're collecting data. We're modeling, so we're trying to push the envelope of what is possible.
Here again is Peter Smith with his thoughts on the future of Mars exploration.
The Pathfinder mission was a huge success. We loved it. Everybody liked the pictures. We watched the rover drive around and explore the rocks up close. And in fact, we had the first traffic accident outside of the planet Earth as the rover hit a rock. So, you know, there was a lot of excitement. It was just thrilling. But then several years later, in 1999, we came on a return mission and we lost the whole mission. So we'd gone from this huge success and the thrill of landing on Mars and taking pictures and doing exploration to a complete failure. We had no pictures, no exploration possible. And it just shows how difficult it is to do science on Mars, and also how difficult it'll be for people to go to Mars. Not a simple thing. We look forward to it, but I'm afraid it may be a long time before we're really prepared to send people.
Can life sustain itself on Mars?
Well, that's a good question. That's sort of the holy grail of our mission, is to try and find if life can survive on Mars as it did in primitive Earth, which was a very harsh environment also. Could it happen on Mars? It certainly could, but it's not commonly found on the surface. It would be in little niches or caves or underground situations where it's protected.
You liked Mars before liking Mars was cool. The movie The Martian just comes out. A lot of people jumping on the bandwagon right now. Probably little kids like you were back in the day watching this. Are you hopeful that this just maybe opens up a new concept into loving science?
Well, that would be a wonderful thing, yes. Science is a great way to learn about the world and a wonderful career, so I really hope it does encourage kids to study their sciences and even consider careers.
The Martian movie did not necessarily contact you directly, but you did have some role in this film.
Well, the Jet Propulsion Lab, who was contacted directly, asked me if I had any of the old photographs of our camera moving around. And I have to tell you, and I'm not totally proud of this, but the camera doesn't move nice and smoothly. It actually is a little jerky as it turns.
But
it was a low budget camera, so it was a little jerky. And when I used to go to JPL during the days of the mission, the project manager, Tony Spears, when he'd see me coming, he'd say, "Oh, Peter," and he'd start moving his head like.
Tell me about the picture that you brought today.
The picture I brought is our flight camera, taken in 1995 as it was delivered to the spacecraft. Right before delivery, we took our last picture of it. And I wanted to point out, it looks very much like the one in the movie. It has the two eyes, which allows a stereo view. It has a neck that turns just like a human head. Gives you a human vision of what Mars would look like. But it has a little different mast. In the movie, they had this beautiful mast that went up and down. We couldn't afford that, so we have a little jack-in-the-box thing that went up. But if you look closely at it, and I want you to zoom in on its so-called face, you see the two eyes, and if you look carefully, you'll see there's a little smile. And those are the vent holes. We could have put them straight across, but I said, look, this is a happy camera. Let's make a smile. So if you look at the camera, you'll see the smile. They didn't get that in the movie. They should have called me directly. I would have pointed it out.
How proud must you be of your work here at the University of Arizona and to see it now in the movies? I mean, you've been proud for a long time, but now people are understanding this.
Well, I was blessed to be born at the right time for space. My career started with the Apollo program and continued till today. The exploration of every single one of our planets, and even one that's no longer a planet, has happened during my career. So I couldn't have chosen a better time to go into space science. It's just been fabulous.
Joining me now is Sara Hammond. Sara's the science producer here at Arizona Public Media. Sara, thanks so much for joining me today.
You're welcome, Lorraine.
Sara, how long has this research really been done here at the university working with NASA?
Well, the planetary, Lunar and Planetary Lab and the Planetary Sciences Department was stood up in the 1960s when Gerard Kuiper was recruited here from the University of Chicago. And Dr. Kuiper was mapping the moon for a lunar landing site. So this goes, back to the dawn of the space age, and that President Kennedy was so passionate about. And it's just continued. The University of Arizona has been involved in nearly all, if not all, planetary exploration missions, so throughout our solar system.
So for the last 3-4 decades or so, many more to come. When we see a project like this one, or the Martian movie, where everyone wonders, what are the scientists here at the University of Arizona thinking? It goes beyond the U of A in Arizona. It's happening in other universities and in the state.
Right. We have a solid planetary sciences department here in Tucson at the university. Arizona State University's Phil Christensen has done a lot of work on Mars exploration. And then the Lowell Observatory up in Flagstaff, of course, is where Clyde Tombaugh first discovered Pluto. And they continue to do important work there as well. So Arizona is pretty well known for planetary exploration and science and discoveries.
And the University of Arizona made some news several weeks back when we heard news of water on Mars. How did that all happen?
Well, interestingly enough, the HiRISE camera, which we've just heard about from Dr. McEwen, circles Mars every few hours. And back in 2010, an undergraduate student noticed these features on Mars, and it looked like they would extend out and then go back away. He went to Dr. McEwen, and they started examining, and what they determined is that is actually water flowing on Mars during the summer. So the salt on Mars allows this water to liquefy. It flows down these slopes during the summer months and then recedes in winter. And those features were first discovered by HiRISE, and then another instrument on the Mars Reconnaissance Orbiter confirmed them.
So it sort of started at the U of A and ended again to see it come full circle.
Absolutely. That was quite had the scientific world buzzing a couple weeks ago.
Certainly. This movie, The Martian, really gaining a lot of ground in Hollywood, but I think also really inspiring a new generation of scientists.
It really is. I sat in on a panel discussion last week over at the Flandreau Science Center. There were a number of students there. And I think the idea that we can learn about other planets, perhaps go to other planets someday, is inspiring for young people to become scientists or engineers and really continue on the work that's been going on since the 50s and 60s with NASA and other organizations.
This panel discussion that you were able to sit in on, you're hearing a lot of these scientists say that this movie was done pretty well considering the circumstances and what they were trying to portray.
Absolutely. It's a film made from a work of fiction, but the author did his homework and did a lot of research, and it's as realistic as it can possibly be coming out of Hollywood. But it was a lot of fun too, and if folks are at all interested in Mars or planets, they ought to go see it.
And we also, all of the professors that we spoke with here at the university talked in length about how it was well done, and there are some concerns, but for the most part, it did a really good job of giving credit to the work that's done here at the U of A.
Here at the U of A and NASA, the folks at the Jet Propulsion Laboratory got a pretty good shout out via the movie. So it was realistic and fun.
Okay, Sara Hammond, the science producer here at Arizona Public Media, thank you so much for your analysis.
You're welcome.
All right, and thank you so much for joining us. For all of us at Arizona Public Media, I'm Lorraine Rivera.